Welcome to iTTV for Form 4 Chemistry. We are starting a new chapter, Chemical Formula and Equation, which is Chapter 3. The title of this lesson is Relative Atomic Mass and Relative Molecular Mass. So in this chapter, Chapter 3, we're going to start by looking at the mass. The mass of an atom, of an element, and then we want to look at the mass of molecules and compounds. Towards the end of the lesson, we'll have a look at the number of particles that we have in a fixed sample of chemical substance, but that a bit later. Relative atomic mass, RAM, mass of an atom compared to the mass of a standard atom. 1. Comparison with the hydrogen atom. Relative atomic mass equals average mass of an atom of the element divided by the mass of one hydrogen atom. Now, the mass of one hydrogen atom is 1. So, if you compare the mass of another atom of a different element, then you can get a relative mass for it. Hence the term relative atomic mass. Relative atomic mass of nitrogen. If you look at the diagram, you will see that one nitrogen is balanced by, on the other side, 14 hydrogens. So, the mass of nitrogen is said to be 14. Relative atomic mass of nitrogen equals 14 hydrogen. But the thing is, we don't use hydrogen as our standard. It's a bit difficult to use because it is a gas. 2. Comparison with carbon-12 atom. Carbon-12 is used as a standard because of its existence in most substances. Carbon-12 is a solid. RAM of hydrogen 1, carbon 12. Mass of one hydrogen atom equals 1/12 times the mass of one carbon atom. Therefore, relative atomic mass, RAM, equals average mass of an atom of the element divided by mass of 1/12 of carbon-12 atom. So this is the key formula for finding the relative atomic mass. It is the average mass of an atom of an element divided by 1/12 of the mass of one atom of carbon-12. Example: how many hydrogen atoms have the same mass as one carbon atom? Well, hydrogen has the mass 1. Carbon has the mass 12. So how many hydrogens would be the same as one carbon? 12 hydrogen atoms will have the same mass as one carbon atom. Let's try another comparison. How many carbon atoms have the same mass as one magnesium atom? Magnesium has the RAM 24, carbon 12. How many carbons have the same mass as magnesium? So that would be 2 times 12. 2 carbon atoms. How many times is one magnesium atom heavier than one helium atom? Now, magnesium has the mass 24, helium the mass 4. Let's just sketch this on the board, shall we? And have a look at how to work this out. Remember, magnesium has the mass 24. Helium has the mass 4. So, how many times heavier is this compared to this? Well, it's just simple math. 24 divided by 4, which is 6. So, the answer, 24 divided by 4, which is 6. So it means magnesium is 6 times heavier than helium. Let's try one more. How many atoms of helium has the same mass as 3 atoms of carbon? So, what do we know? We know that carbon has the mass 12, which means 3 carbons would be 3 times 12, which is 36. Helium has the mass 4, which means how many times heavier? How many helium will be equal to 36? So, 36 divided by 4 gives you 9. So, 9 helium will be the same as 3 carbon. Mass of 3 carbons equals 3 times 12, 36. REM of helium is 4. 36 divided by 4 is 9. So the answer is 9 helium atoms has the same mass as 3 atoms of carbon. Relative molecular mass, RMM. Relative molecular mass equals average mass of molecule divided by 1/12 of a carbon atom. So the average molecular mass is the mass of a molecule. So what you do is you just add up all the masses. Let's do a quick example before we do some examples on the slides. Let's say that we have a molecule. Let's take carbon dioxide. We have carbon, oxygen, and oxygen. So you have CO2. The relative molecular mass of this molecule is just the addition of all the masses. Oxygen has a mass of 16 plus carbon 12 plus 16. Add them all up and you get 44. So the relative molecular mass of carbon dioxide is 44. Just add up all the different masses and you'll get your molecular mass. Let's do a few examples. Hydrogen. Molecular formula H2. Types of atoms, hydrogen. Number of atoms, 2. So the relative molecular mass will be 2 times 1, 2. Nitrogen, N2. The number of atoms is 2. So the relative molecular mass will be 2 times 14, which is 28. Good. So I think you're getting the idea. We just add up everything. Oxygen is O2. The number of atoms is 2. So the molecular mass will be 2 times 16, 32. Fluorine, F2. Number of atoms, 2. Now, what would be the mass of a fluorine molecule? 2 times 19, 38. So those are 4 simple, straightforward molecules, element molecules, meaning you have the same type of atom. Similarly, chlorine, Cl2, 2 times 35.5 equals 71. Bromine, Br2, 2 times 80 equals 160. Now, water is made up of 2 hydrogens, so that's 2 times 1, and 1 oxygen, which is 1 times 16. 2 plus 16, 18. So when you have a compound where you have 2 different atoms or more, you need to just multiply them by their number and then add them up for the whole compound. Carbon dioxide. You have 1 carbon, which is 12. 1 times 12. You have 2 oxygen, so 2 times 16. Add the 2 numbers up. 12 plus 32 gives you 44. Ammonia, NH3. Now try and do this yourself. Nitrogen has the mass 14. Hydrogen has the mass 1. So you have 3 hydrogens, 1 nitrogen. Your answer should be 17. Very good. Let's try a more tricky one. Magnesium nitrate. Mg bracket NO3 close bracket 2. So let's go up to the board and work through this one and make sure we are clear on the number of each of the atoms. And then we can work out its relative mass. So we've got the formula Mg bracket NO3 2. So what do we see? We have 1 magnesium. Anything that's in a bracket, we have to multiply it by the number outside. Nitrogen times 2, which means we have 2 nitrogens. Inside we have 3 oxygens multiplied by 2, so our oxygen equals 6. Now that you know how many of each you have, multiply them by the RAM and then add everything up. Let's have a look at what we should get. 1 times 24 plus 2 times 14 plus 6 times 16. 24 plus 28 plus 96 equals 148. So these are slightly more tricky, but if you do them systematically, work out the number of each element first and then multiply it by the RAMs and then add everything up, you should get it correct every single time. Mole and the number of particles. Chemists measure the number of particles in moles. Mole. 1 mole, the quantity of substance containing 6.02 times 10 to the power 23 particles. The value 6.02 times 10 to the power 23 mole negative 1 is known as the Avogadro constant. Mole. You're going to be hearing this word quite a lot in your chemistry. We generally use moles for our calculations. They tell us the number of particles. Why is it important? Because when a chemical reaction takes place, particles are colliding with each other. And we need to know that the ratio of particles colliding is fixed or the same or correct. If you have 10 particles on one side, you want 10 on the other side. If you have 1 mole on one side, you know you have 6.02 times 10 to the power 23. Which means if you have 1 mole on the other side, you know you have the same number of particles. 1 mole of atomic substance, number of atoms. Right, now this is a bit tricky, so we're going to go through this slowly. What we want to do is be able to clearly work out the number of particles based on the statement that we are making. So I'm going to go up here and clean the board and then we'll start. So the first thing that we are saying is, in the first part, 1 mole of atomic substance. So we have 1 mole of atomic substance. So atomic, remember, they are just atoms by themselves. So something like that. But 1 mole. How many of these will I have if I have 1 mole? Now, according to what we are saying is we must have the Avogadro constant number, which means if I have 1 mole of atomic substance, I must have 6.02 times 10 to the power 23 atoms. So understand what we are saying. 1 mole means I must have this many atoms. So let's go up to the slide again and have a look. 1 mole of molecular substance. Now, if we are looking at a molecular substance, let's take a simple molecule like oxygen. If I have 1 mole of, let's say, oxygen molecules. Now remember, an oxygen molecule is just 1 oxygen and another oxygen combined together. Let's put the symbol O in both of those. There we go. That is a molecule of oxygen. If I have 1 mole, how many of these molecules will I have? Well, remember, 1 mole is Avogadro's constant. So I must have 6.02 times 10 to the power 23 molecules, like so. I hope you're sort of getting the idea. Anything that says 1 mole must contain this number of, if it's atoms, atoms. If it's molecules, molecules. What about 1 mole of ionic substance? Well, let's take a simple ionic substance, sodium chloride. If I have 1 mole of sodium chloride, remember sodium chloride is an ionic compound where I have positive sodium and negative chlorine bonded together due to electrostatic force of attraction. Well, how much of this am I going to have? I must have, correct, 6.02 times 10 to the power 23 ions. That means I've got 6 times 10 to the power 23 of these ions inside here, of each. I've got 6 times 10 to the power 23 of sodium, and I've got 6 times 10 to the power 23 of the chloride for each of them. So let's make a note of that. 6 times 10 to the power 23 ions, each one. Do you get the idea? If you have 1 mole, you must have the Avogadro constant value of particles. If I have 1 mole of ions, how many ions will I have? Think. It says 1 mole, so your answer must be 6.02 times 10 to the power 23. If I have 1 mole of shirts, that's a lot of shirts, but that is again 6.02 times 10 to the power 23. I hope you're sort of getting an idea about how to work out and to relate the concept of 1 mole to the Avogadro constant value. Let's have a look. How many mole of carbon atoms equals 1.2 times 10 to the power 24? Now, this part, a bit tricky. Let's go back up to the board for this one. So, in this case, what we're being told is we have 1.2 times 10 to the power 24, which means we have slightly more than Avogadro's constant. What we need to do now is relate this back to mole. Very simple way of doing it. You know, 1 mole equals 6.02 times 10 to the power 23. Therefore, how many mole equals 1.2 times 10 to the power 24? If you do a simple cross multiply, you will find your unknown equals, if you bring this up and bring this down, 1.2 times 10 to the power 24 times 1, which is the 1 mole, divide by Avogadro's constant, 6.02 times 10 to the power 23. You get the answer 2. So how many moles? 2 moles of carbon equals 1.2 times 10 to the power 24 atoms, or in this case, particles of carbon. Let's try another one. How many moles of water molecules are in 2.4 times 10 to the power 24? So, once again, we use the same idea and the same method. Let's go back up here. Remember what we have? We'll start with the basics. 1 mole equals Avogadro's constant. Good. 6.02 times 10 to the power 23. What we are asking is, how many mole equals 2.4 times 10 to the power 24? Once again, this is your unknown. To find it, do a simple cross multiplication. Bring this value up, bring this value up here, and take this value down here. Please do the cross multiplication. Get your calculator and practice it. Okay, remember, cross multiply these two values and you should be able to find the answer. Have you done it? Good. Let's check. The answer in this case will be 4 mole of water molecules. Good. So 4 moles of water molecules have got the Avogadro number times 4, which is 2.4 times 10 to the power 24. So remember the key things here. The first thing, relative atomic mass. This is the average mass of an atom, of an element, divided by 1/12 of a carbon-12 atom. Then the relative molecular mass, whereby we are doing the same thing. The average mass of a molecule divided by 1/12 of the mass of carbon-12. With the molecule, remember, add up all the different elements' masses to get your complete molecular mass. Be systematic. Work out the number of elements inside first. Remember the example of the magnesium nitrate we did earlier. We worked out how many magnesium, how many nitrogen, how many oxygen, and then we multiplied and added the numbers up. Finally, remember the first key thing about the mole. 1 mole contains 6.02 times 10 to the power 23 particles. If it's atoms, it has that many atoms. If it's molecules, it has that many molecules. If it's ions, well then it has that many ions in it. And finally, when you are given a question where they give you the particles and they ask you to find the moles, remember the simple way of doing it. 1 mole is always equal to 6.02 times 10 to the power 23. So if this is unknown and this is known, you can cross multiply. If this is known and this is unknown, you can still use the same method because it's the same cross multiplication. That's all the time we have this lesson on relative atomic mass, relative molecular mass, and Avogadro's constant. Thank you for watching iTTV.